All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to continue working on my auto clipper. We're gonna continue prototyping. I'm slowly making progress, and going step by step. Give me a second. Let me open up my stream on my phone so I can see the chat. And we should be beginning here shortly. Um, okay. And let's also get that. Give me a second. Okay, yeah. Sorry about that. Usually when I start the stream, then I'm pretty chatty, but I was just starting up some things which are taking some time. Okay, so, um, dude, today I I made some progress towards cleaning some parts of my room. There have been a bunch of things that ever since I moved into this house, I'd brought them over from my old house, and I'm the kind of person that likes to learn and experiment and stuff. And ever since I got into my electronics hobby, I would just do this thing where I would keep collecting a bunch of old electronics, not because I had specific use case for them. It was mainly just like, okay, in the future, I might open this up and study it, or maybe I might need to extract components from it, or maybe I could just hack it and do something fun with it. And I still stand by that thought process. It's just that you need to know when to put a limit to that. And with me, I kept forgetting that I had older stuff that, I wanted to study and hack and take apart and extract components from and stuff. And so a bunch of stuff just kept piling up. And so there was a mess in multiple different places. And when I wanted to move things around, when I wanted to look for shelves to keep things, I would already have boxes there that had things in them. And so I had to go through a bunch of these things and like find stuff that I want to throw and stuff that I want to keep. I actually, okay, something that I will also be throwing is actually, I just remembered I need to take out the RAM stick from that. Yeah, yeah, holy shit, dude. There's a working RAM stick in that. I'm just realizing this. There is a working RAM stick in that box. Anyways, there's a bunch of like old motherboards and really old computer hardware, like from maybe the early 2000s or maybe the 90s. So it's like really old hardware, and it was the same thing. I wanted to study older hardware and see how it worked and stuff like that. Not like I could get those systems to magically start working, because I mean, I got them from a junk shop, a scrap shop kind of thing. These were discarded computers, so there was definitely something wrong with them. But I was always fascinated with like older computer hardware. Not that I could fix it. Again, not that I could fix it even if there was any issue with it, but I just wanted to, open it and look at it and maybe take pics of it and stuff like that. It was just something I was interested in. I don't need to keep all of it, so I'm gonna be throwing the motherboards. I do want to keep the RAM because it's small enough, and because one of those 1 GB sticks, if it's still working, assuming it's still working, I could actually use it because it's a DDR2 RAM stick, and I have one machine that does actually require DDR2 memory. So just in case if I ever need more RAM, I can install that stick and we should be golden. And I've also kept the processors that I've been able to extract, at least the ones that I was able to extract, because there was one motherboard in which the processor was actually soldered onto the motherboard, so like you can't pull the thing out. The processor is soldered on there, and then they put the heatsink on that, and of course with thermal paste and stuff. Then they put the heatsink on that, and then they put the fan on top of that. I also found my very first GPU. I am still not entirely sure if I want to throw that. Um, Luckily, it's small enough that I can keep it and not be too worried about um, not be too worried about it taking up too much space. There is actually one place where I could keep it. I could actually keep a bunch of these old hardware things because I have like much older RAM. I have older processors, like three or four old processors. Some of them are so old that they're pin processors. Like back in the day, we didn't have pinless processors. These days, it's all pinless. They don't do the pin thing anymore because it's incredibly risky, and there's probably um, there's probably more technical reasons surrounding it as well. But one major issue with the pin processors was that um, there was always the chance of the pin breaking. And if the pin on the processor breaks, then it's kind of a lost cause. Unless you know some sort of way to jerry rig it and get the thing to work again, yeah. So these days we have, and for the past decade plus, maybe 2 decades, now that I think about it, actually 2 decades, we've had pinless processors, so you don't need to worry about that anymore. You just place it onto, like, it's blunt copper making contact with flat copper. And I mean, I don't know if they've changed the design these days or what, but like, it's definitely not pin processors anymore. So you have very little chance of damaging the processor in that specific way. Well, anyways, I've been making a lot of progress with cleaning up my room and reorganizing stuff. And yeah, dude, I'm pretty happy with the result because one of the things that actually got me to kind of make an effort to declutter my room and get rid of a bunch of things was how much it was affecting my AC's ability to cool the room. Because there were two things at play, and like I did a bunch of research uh, surrounding this. That's how I learned that this is really a thing. This got me to learn about stuff like thermal mass, for example, something's ability to hold a certain amount of heat. Um, and I learned that, the more items you have in a room, the more heat is going to be radiating from them because the items are constantly exchanging heat between each other. If you have multiple items within a closed container, then the heat exchange is much slower. So that's one way to go about decluttering. But if you have them out in the open, and especially if you have like bigger items as well, they're gonna, first of all, they're gonna be taking up space. So there's lesser room for airflow, or colder air to, take space there. That does mean that while the area can get cooled pretty quickly, once the compressor shuts off, it can also become warm pretty quickly because of a low amount of total air. And then, of course, there's a thermal mass, because of which the objects start radiating heat. And if you have a lot of objects, basically clutter in your room that are radiating heat, then whatever cooling of the air that your AC is doing, that's going to slowly start to become less effective. Your room is going to remain cool for a lesser amount of time once the compressor shuts off. Another issue is that, okay, we've turned this into fucking, like, I don't even know what we're talking. Okay, we're only 10 minutes into the stream. It's fine. Another issue with having clutter is, or well, I guess it depends where you place it. But yeah, another issue with having clutter is airflow. you might be impeding the airflow, the natural airflow of the AC, because apparently this is a thing. The AC pushes out air, but then because of the way that air works, like the way that it's been explained is that the AC is pushing out air, but there's already air within the room. So in order to make space for the new air, the older air starts to get pushed out, and there's a circular kind of motion going on. I don't remember what the physics surrounding that was, but apparently um, the the air naturally wants to come back to the AC, and it naturally wants to take the path of least resistance. So if you have lesser, if you're not actively impeding the airflow, if you haven't placed objects, which I only learned this because I had placed objects in like specific locations for other reasons, not for impeding airflow specifically, but it just so happened that they were actually impeding airflow, and I only realized this once I started removing those objects and keeping them in like different places, or even just discarding them. And yeah, um, ever since I learned about this, I've been making more of an effort to kind of declutter my room and rearrange things, reorganize things, and yeah, the decluttering process. It just so happened that it resulted in my room being a lot more organized and having a lot less clutter in the room. So I'm pretty happy about that, and my AC is cooling pretty well now. So I got to learn something. So that's great. Give me a second here. We are gonna jump right into, well, 10 minutes late, but we're gonna jump right into um oh damn. Okay. That happened. That's gonna be a problem. Where can I look at this? I can look at it here. Okay. Yeah, fortunately, you guys cannot see the problem that's occurring, which is great. Oh, hold on. We have another problem occurring. We are dropping frames. So I need to very quickly reduce the load on my connection. I'm just going to do a couple of things here and reduce the load. I've also been making progress with, moving forward with Rust in terms of learning more advanced things about the language, in terms of learning more advanced things about the language, and also learning about various libraries that can be used for various purposes. And I have a couple of ideas that. Oh, speaking of ideas, I need to write down which mind map did I put the ideas thing into? Give me a second here. Let me just, okay, it's definitely not this one. Rust project ideas. There you go. I completely forgot about this. I had an idea for a disk usage analyzer TUI, and it's kind of interesting. Once you get into like the tech behind this, you very quickly realize that you can't solve all the problems with more CPU and more RAM. Sometimes you're straight up just limited by the actual I/O capabilities of your let's say hard drive, for example. But yeah, okay. There was Rust Wave game, and then there was Rust um, Rust mouse um, emulator, MMB and wheel. Okay, for this, the libraries that I want to use, just so I don't forget, one is Enigo. Um, Hold on. Yeah, okay. One is Enigo. Then there's RDev for the listener events and stuff. And Oh, actually, I think that's it. Yeah, yeah. I think that's it. I think okay. I need to check if Enigo has Tokyo support, which Tokyo is another thing we need to get back to, dude. Holy shit. I kind of just like pushed Tokyo to the side because I was doing a bunch of other things. But okay, anyways, let's get back to this. So yesterday, what I was doing off stream is um, I was looking into splitting the audio and the video of the VOD and also slicing the VOD. So taking out like a 10-minute chunk. I'm going to be taking out a 30-second chunk. Or actually, no, I'm not going to be taking out a 30-second chunk. I'm going to be feeding a 10-minute chunk into the model. Um, I kind of want to feed a whole 2.5 hour chunk into the model and see how just how much it affects the oh yeah, there is that problem. If the process fails anywhere in between, I don't think I'm gonna get the entire result, so that's gonna be a problem. So instead, what I could do is I could divide up the video into 30-minute chunks. Anyways, I was looking into slicing. Okay, regardless whether it's 10-minute slices or 30-minute slices, I was looking into slicing the video, and I think due to the way I forgot exactly what the reason was, but it had to do with like the sample count and the way that the data is being read. Even though I said 10 minutes, what was really exported was 9 minutes, 59 seconds, and something. Um, 59 seconds, and so it was off by like, I don't know, half a second or um, I don't maybe 1 second or 1.5 seconds or something. But the point is, it wasn't a full 10-minute thing, and Gemini gave me a pretty good explanation, explaining exactly why this is. And then Gemini also mentioned that if it's not just one chunk, because like I was then mentioning later that okay, what if I want to pull another slice immediately after that 10-minute timestamp? Am I pulling after 10 minutes or am I pulling after 9 minutes 59 seconds and whatever microseconds? uh, is it microseconds? I don't know. Nanoseconds? Hold on. Seconds to milliseconds. Yeah, a thousand milliseconds is 1 second. So actually, I don't know if that was I don't know if that was milliseconds. What's below that? Microsecond is below that, and nanoseconds is below that. Okay, it was probably milliseconds. But anyways, I was wondering that okay, for the sake of being accurate, because the timing isn't exactly at the 10-minute mark. So the next clip, where should I start exporting from? The next slice, where should I start? What should be the start point of that next slice? That's supposed to be immediately after. And then Gemini explained that no, you shouldn't use that 9 minute, 59 seconds, and whatever milliseconds. Um, I forgot what it said to do in that situation instead. However, later, Gemini then gave another suggestion, which was to use a feature within FFmpeg itself that would help me export multiple chunks at once. So turns out FFmpeg has that functionality built into it. You just need to. I forgot what it's called. Hold on. I'm looking at the conversation here. Um, so it's something called segment something. So you specify F. I forgot what the F flag was for. Can I do man FFmpeg? Yes, I can. Okay. Now how do I go look for the wait, okay, the transcoding process in FFmpeg for each output can be described by the following diagram. Input file, demuxer, encode data packets, decode, pass it through the decoder, then get decoded frames. Um, okay, so we decode it first, get the decoded frames, then encode. Oh, this is a transcoding process. Okay, okay. Um, okay, then we have filtering. Man, this is okay. Holy shit, this is a very sophisticated piece of hardware. Hardware? Software. Siva, hello, hello. Welcome to the stream. How's it going? We are currently doing some prototyping for my just a second. Yeah, we're currently doing some prototyping for my autoclipper program that I'm working on. Right now, I'm trying to get the logic down for slicing a 2.5 hour VOD into, let's say, 10-minute chunks or even 30-minute chunks. I want to see how well that works. And it turns out FFmpeg um, does have functionality to allow you to slice to slice the files, and it also handles the what do you call it? It also handles um, the timing related issues, because if you tell it to slice exactly 10 minutes, it's not going to slice exactly 10 minutes. It's going to slice from 0 to 9 minutes 59 seconds and whatever milliseconds. That's kind of what happened in my case. And so where do you start the next clip from? That becomes a bit of an issue to calculate. So instead of having to calculate that, I can just tell FFmpeg to kind of create how many slices I need. FFmpeg definitely is. It is why most video software, whether it's a I think you meant it is why it's the most used. Maybe, I guess. But yeah, FFmpeg, dude, yo, holy shit. There's so much that this program can do, um, especially with like the insane amount of different combinations of like arguments that you can give to create different types of functionality, all from the command line itself. And they have this thing of like filters, where you can apply multiple types of filters to do various things with the video, or I think even the audio. It's crazy. Like if you have multiple operations that you need to do, like in my case, it would be first slicing the video and the audio, and then the audio, because it's going to be in something like AA something, I forgot what that format is, or some other M4A maybe. I don't remember. It's not going to be a wave file. That's the point. Because it's not going to be a wave file, so I need to transcode this thing to wave. Another reason I need to transcode the audio to wave. No, sorry. Another reason I need to transcode the audio is because it's probably going to be AAC. It might be AAC. Yeah. Thank you. So it's probably going to be AAC or M4A, one of these two. Actually, I could check it right now. Hold on. Um, it'll be funny if it turns out to be uh, Wave anyways, but like, yeah, let's see. Is it in data? Yes, it's in data. Um, what am I looking at? VOD, test VOD. So FF probe, I believe. Test VOD O1 MP4. Yeah, so it's AAC. I need to transcode this. So I need to transcode this for multiple reasons. One is because I don't know if Hugging Face transformers pipelines accepts AAC. But another reason I need to transcode it is because the model doesn't need 48,000 hertz. It doesn't need 48 kilohertz. It needs 16 kilohertz. Um, Also, it may not necessarily need stereo. It usually uses mono unless specified otherwise. So there's a bunch of stuff that I have to do, because of which I need to transcode the audio. So there's multiple operations, right? There's first the splitting of the video and the audio, and then there's the transcoding of the audio. And the way that FFmpeg is designed, apparently you can like chain a bunch of these commands together into like one big command. You don't always have to do multiple commands, which I found super interesting. It most likely accepts MP3 and hopefully Opus and OGG. I actually haven't tried either of those. MP3 maybe, yeah. I think I might have read that somewhere. I don't remember exact. Yeah, hold on. Let me I could just Google this real quick. Um Hugging Face, Transformers, Pipeline, Audio. Oh, yeah, I already Googled this. Audio format. AIFF, FLAC, MP3, OGG, and WAVE, as well as raw audio data in Python. So if I can find a different library to convert the thing into like a NumPy array, it'll probably accept that as well. Um, but yeah. So now what I'm trying to do is, I was actually reading this other conversation that I was having with Gemini, where it was explaining to me why exactly, even though I told FFmpeg to, um, OGG works better under lower bitrate than MP3 bitrate. So I know about sample rate. Okay, let me look this up. What would be the difference between bitrate and sample rate in audio? Unless we are talking about like the thing being transferred, then the bitrate is like a different thing. But hold on, let me. In audio, what is the difference between bitrate and sample rate? Because I know what sample rate is, I know what bit depth is. What is bit rate? Okay, in digital audio, sample rate and bit rate describe two different parts of how sound is converted into data. A helpful way to think about it is that sample rate is about time, while bit rate is about data speed. Okay, I know what sample rate is, so I don't need to read that. Then bit rate, the speed of data. Bit rate is the amount of data processed per unit of time. Okay, usually measured in kilobits per second. It tells you how much information is being delivered to your ears every second. What it does, it generally determines the overall fidelity and file size. A higher a higher bitrate means less compression and more detail. Common standard 320 kilobits per second. Okay, 320 kilobits per second is considered high quality for MP3s, while 128 kilobits is uh, is standard for basic streaming. The formula for uncompressed audio. Wait, okay, so this is, as I had mentioned before, like this is more of like a transfer thing, right? Speed of data. But then what does this mean in terms of, okay, let me try and ask in this way. This so bitrate makes sense when there's actual transfer of data. What does it mean um, in terms of the data that's already present in the file? In terms of a file sitting on your hard drive, bitrate represents the density of the information. It is the mathematical weight of the audio that determines how much disk space is consumed for every second of sound. Think of it as the storage budget. If a file has a bitrate of 320 kilobits per second, it means that for every second of music, exactly 320 kilobits of your hard drive space are being used to describe that sound. Now, okay, if that is the case, so okay, this is, wait, let's read this again. Um, it determines how much disk space is consumed for every second of sound. But then wouldn't you be able to calculate that from the sample rate? Because the sample rate is well, from the sample rate and the bit depth. Because the sample rate is the number of samples per second, right? And then the bit depth tells you the depth, the precision of each of those samples. So wouldn't you be able to calculate it from that? Let me see if that's exactly what Gemini mentioned. Oh, there you go. Yeah. So it's exactly what I was thinking. It's sample rate multiplied by bit depth multiplied by number of channels. That gives you the bit rate. So in this case, when if we are talking about storage, bit rate is not mentioning bit rate is not talking about transfer speed. Bit rate is talking about the amount of space that or the amount of data that 1 second of this audio contains. Or rather, I should say the size of 1 second of audio data. That's interesting, dude. Okay, so we learned about bitrate. Holy shit. Thank you for that. Siva, thank you for that. I'm going to keep this in mind when I'm looking into like audio data. So in this case, we are looking at 159 kilobits per second. Okay, what happens after I transcode this? What was the name? VOD audio. Right, so let's do VOD underscore audio dot wave. This is 256 kilobits per second. Interesting. BRB add. All right, cool, cool. Keeping a master copy is a good idea. Oh yeah, for sure, for sure. I'm definitely not gonna operate directly on the main copy. I'm if like anytime I'm doing anything, I'm just gonna store the result into a separate file. Um, where what was I there was something I was gonna look into with bitrate. Okay, let me ask one final question to Gemini. So when it comes to communication, bitrate is talking about the transfer speed, but when it comes to storage, bitrate is talking about the amount, or I should say, about the size of 1 second of data. Maybe not exactly that, but like, yeah. Welcome back. Exactly. You've nailed the dual nature of bitrate. Whether it's moving through a cable or sitting on a disk, bitrate is essentially a measure of data density over time. Here's how that one number translates into both speed and space. In terms of storage, it's the footprint. When a file is saved, bitrate tells you the storage cost of every second of the song. Okay, let's test this out real quick. Do I have a free terminal somewhere here? I have this Python thing open. Um, I have this, which was, what was this? Oh, this is the, yeah, I can close this. And here I can open up a Python instance. Yeah, let's do that once this closes properly. Okay, so if we are looking at, um, let's skip the milliseconds and let's look at just two 2 hours and 32 minutes. 2 hours and 32 minutes. So to get hours out of minutes, you would, do you multiply it by 60 or divide it by 60? Hold on, hold on. Um, if we say 2 hours, 2 hours is 120 minutes, right? How do we get to 2 hours? By doing this. So we multiplied. All right. Um, so we have 2 hours. 2.5 multiplied by this would give us 150 minutes. It's not 2.5 hours though. It is 2 hours and okay, so the point five thing is not going to work because it's not 0 to 100, it's 0 to 60 when we are counting minutes. So 32, okay, whatever. It's 120 plus 32, so 152. Right, 152 multiplied by, what does it say? 256 kb per second. Oh shit, I have to get the number of seconds as well. So this is 152 minutes. Let's get the number of seconds. 9,120 multiplied by 256. That gives us whatever that number is. So that's bytes, kilobytes, and then megabytes. So 2.3, I think. Yeah, we can say 2.3, 2.4. Is the file size being mentioned here? We can open up Yahtzee and check. VOD audio. I forgot how you check a specific file. Oh, okay, there it is. That's really light, so I can't read it very well. Give me a second. Back up. Just a minute. Oh God. Okay. I accidentally hit a keyboard shortcut for this in my browser instead. What does that say? That says a couple hundred MB, I think. Give me a second. Can I use the disk usage thing? Okay, get file size in. Okay. This is the most common method for a quick human readable size report. Then we have stat. Then we have WC word count. Then for directories, disk usage is for directories. I'm aiming it at, oh, I could do the entire directory, right? SH. Uh, then there's SCH. What does the C add? Provides the total size. H makes it human readable. What is this? This doesn't mention. Here, run this command to see the summarized human readable size of all files and directories in the current location, along with the total sum. Okay, I think just SH is enough. So we can do this and that. This does not display it for every. Okay, let's try this. Yeah. So what we are looking at is 279 MB. My thing was way off here. Oh, I didn't take into account that I was reading kilobits per second. It's yeah, 256 kilobits per second, not bits per second. Because it's kilobits per second, so then I would have to start counting from kilobytes, right? So then what we are looking at is because 1,000 would be 1 MB, 1,000 would be 1 MB, right? I think, yeah, 1,000 would be 1 MB, and then 1,000 of that would end up being 1 GB. How are we getting? Because this is saying 2 million. This is saying 2.3 million. Uh, give me a second. I'm just trying to think here. So we have 9,120 seconds. If every second stores 256, if every second stores 256, oh, 256 kilobits. It's not kilobytes though. I have to then convert that to bytes. Okay, so let's do what would this end up being? Okay, so let's say 2334720. 2334720 uh, kilobits to um, 2 megabytes. Let's just be done with this. 291.84. Yeah, there was a confusion there because this is kilobits, not kilobytes. And so the result that I was getting was, I think, because that would be considered 34 megabits, and then 334 megabits, and then it would be 2.3 gigabits, right? So would I be right to say 2.5 or 2.334 uh, gigabits to megabyte? Yes. Okay, I know one is 1024. I know one is 1024 to get the next size up. Yeah, so okay, I had a confusion here in terms of because I was reading kilobits per second, but then when I did my calculation here in the Python interpreter, what I was assuming was that it was showing me bytes, but it wasn't showing bytes because the calculation was 256 kilobits per second, so it was showing me 2.334 gigabits per second. And I had to convert that to megabytes or just bytes in general. Okay, now Uh, I at this point I've forgotten why I was even doing this, but uh, we are gonna. What was I? So this was the bit rate, and that was super interesting to learn because I had no idea that bitrate actually applies in terms of storage as well. I only knew that it applies um, in terms of communication, like when you're streaming. So this was interesting to learn. I'm going to keep that conversation open so I can read it after stream, but for now, I want to continue reading. Okay, so I was asking Gemini why, even though okay, let me do the probe thing. So if you look at the duration over here, yeah, if you look at the duration here, I've tried to highlight it. It says two. Did I do the wrong? Yeah, I did the wrong one. Wait, hold on, my bad. FF MPEG, no, FF probe. 10 minutes. Right. So if you look at, no, it's saying duration 10 minutes, but um that's not what the results said when I did the transcoding. Can I go back to the transcoding thing? I think this was it, right? This wasn't transcoding, slicing. Sorry. Uh so I'm slicing VOD audio. I'm slicing 10 minutes out of it, and I made this mistake previously as well. Yes. Okay. If you look here, it it doesn't say 10 minutes. It says 9 minutes and 59 seconds and 93, what I'm assuming, 9300 milliseconds? No, 930 milliseconds. I'm not sure. It's close to 10 minutes, like super close, right? But not exactly 10 minutes. And so I was confused about why this was the case. And so I asked Gemini that, hey, what's the situation here? What's going on here? So Gemini explained it in this way. Um, Let me scroll up where the actual explanation is. I did this, I did this. Okay. The reason you see time so and so, 9 minutes and 59 seconds and whatever, instead of exactly 10 minutes is due to audio frame alignment. In digital audio, data is stored in blocks or frames. When you request a specific timestamp, FFmpeg cuts at the nearest possible boundary of those audio samples. The math of the missing 0.07 seconds. It's 0.07. Oh, yeah, 0.07 seconds. Okay. So it's barely even like 1 second. Anyways, your file is 16 kilohertz, which is 16,000 samples per second. The output size you got is 18,750 KB. So 18,750 KB multiplied by 1024. Why are we multiplying it by 1024? To get bytes. Okay. 18,750 KB. I guess I can do the calculation here. Um, so this is our sample size, our sample rate. That is 16,000. And then our output underscore size is 18,000. What is 18,750? 18,750. Oh, output size KB, I guess. Output size KB. And so then we do output size KB multiplied by 1024. And that gives us exactly this. It gives us 90. What is this number I'm looking at? Hold on. Let me try to count the number of zeros. That's three zeros and then 200. So 19,200,000 bytes. that's the size of our I'm assuming it's the 10-minute slice. So that's the size of our slice, right? And then we try to split this down or further like reduce it to figure out exactly what the calculation is. Since it is 16-bit, each sample is 2 bytes. I didn't take the 16-bit part into account. 16-bit. Each sample is 16 bits. Um, BRB. All right. See you in a bit, Siva. Um, I'm trying to wrap my head around this. So, okay, we have bytes, right? And then we divide it into two because we know that each sample, because otherwise we would be doing 1 byte per sample. Which, okay, this raises the question, if the majority of, I mean, obviously the majority of the audio data um, is going to be taken up by, or the majority of the bytes in the file are going to be taken up by audio data. But then exactly how much data does how many bytes does the metadata of this audio file take? Because each format has like a different type of a different makeup of metadata, right? Give me a second. Yeah, each format has a different makeup of metadata. Each format might have like a different type of header, and each format handles audio data in different ways, right? So all of this data has to be stored. Like this will take up a certain amount of bytes as well. Maybe not a massive amount, um, but it does take up a certain amount of bytes. So like, where does that get counted in this? Anyways, okay. So 19,200 19 million, 200,000 divided by 2 gives us 90, it gives us 9,000, 9 million, 9,600,000 um, samples in total. All right. So we do this. Actually, no, we do this. And let's say total underscore samples equals this divided by 2, right? Our total samples is that 9,600,000. Great, awesome. Uh, then then we divide it by the sample rate. So 9,600,000 samples divided by 16,000 samples per second. If it's 16,000 samples per second, then we divide 9,600,000 by 16,000 to get, so we divide it by the sample rate, and that gives us 600. So that gives us the number of seconds. If it's um, oh, so the total number of samples divided by the sample rate gives us the total length of the audio. So that is 600 seconds, which is exactly 10 minutes. The 0 point, or let's say the 9 minutes and 59 seconds, 59.93 seconds, in fact. You see in the console is just a slight rounding or reporting quirk in how FFmpeg calculates the timestamp of the last packet processed. The actual raw data in your WAV file contains exactly 10 minutes worth of samples. Okay, all right. A vital correction to your command. Oh, okay. Yeah, never mind that. That's okay. Then, now we get to the interesting part where I asked, okay, now let's say I need to take 30 minutes out of a 2.5-hour VOD, but in 10-minute chunks. How do I account for this timing issue? Just start at 0 point, or just start at 9 minutes and 59 seconds or 59.94 seconds. I said 94 because like it stopped at 9 minutes 59.93. So I was like, okay, do we start at that um, 0.94? And the response was no. You definitely should not try to manually account for those tiny millisecond offsets like 9 minutes 59 seconds and 94 milliseconds. If you do that, you are almost guaranteed to create gaps or overlaps in your audio that will confuse your ASR model's timestamps. ASR, for anyone who doesn't know, is automatic speech recognition. That's what we are preparing this audio for, because we're going to be feeding this into an ASR model so that we can get a transcript of the entire audio. Okay, then the rounding you saw in the FFmpeg console is a display artifact. When you tell FFmpeg to cut at 10 minutes, it is cutting at the sample level. The clean cut rule: to get perfect back-to-back chunks, use integer-based timestamps for your start times. FFmpeg's internal logic is smart enough to know that the sample immediately following the end of chunk 1 is the start of chunk 2. Okay, so I guess um, this is where Gemini suggested that use that other thing, and like this is where I forgot what it's called. Actually, yeah, I had the hold on, I had the man page for this thing open, right? Um, FFmpeg. Oh, F. How do I look for just the F flag? Okay, let's try. Was it this? Filter. Is it filter? No. What's the next one? Filter, filter. Okay. Filter, 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 filter. Maybe I could just ask, hold on, why am I going through this whole thing? I could just ask, so it's F segment, right? Let's open up a new conversation. In FFmpeg F segment, what exactly does F stand for? And then we mentioned the segment time thing as well. Okay, it stands for force format. Its the its primary job is to explicitly tell FFmpeg which muxer for the output or demuxer for input to use, rather than letting FFmpeg guess based on a file extension. Why use it with segment? Normally, FFmpeg looks at the end of your file name to decide how to package the data. However, segment is a special virtual muxer that doesn't that doesn't have a standard file extension. It is used to split a single stream into multiple chunked files, which is exactly what I'm trying to do. That's quite literally my use case. And I mean, I'm not entirely sure if I'm really even going to be using this, but I want to do it for now just because I don't know if it's a good idea to feed a 2.5 hour VOD into. I'm going to test this out today after stream, but like I don't know if it's a good idea to feed a 2.5 hour, not VOD, but like audio file. This is specifically the audio file. It's the audio portion of the file. I don't know if it's a good idea to feed 2.5 hours worth of um, audio data all at once into the pipelines method, because I don't know if it's going to handle things gracefully if somewhere in between or even towards the end, if there's some kind of error or crash or something, is it just going to discard all the other data? Because um, for anyone who doesn't know, it's processing 30-second chunks. It's not processing any more than 30 seconds. So even if I'm giving it like 10 minutes, it's still processing 30-second chunks. It's processing and then stitching the entire thing cleverly so that I get the entire like 10 minutes worth of transcript. And it makes sure it uses NLP to make sure that there's no overlap or no broken words or anything like that. So that's great. That's pretty awesome. That makes the job so much more easier for me, and it means that I don't have to take on the headache of doing all of this stuff. But I don't know if it's going to give the final, if it's going, if let's say I feed a 2.5 hour VOD into it, a 2.5 hour audio file into it, and then let's say at 2 hours and I don't know 10 minutes, all of a sudden there's some sort of error because of which it cannot continue. But keep in mind, it has processed 30-second chunks from time 0 to time 2 hours and 10 minutes. That is a lot of 30-second chunks, right? That's a lot of data that's already been prepared and stitched and processed and all of that stuff. Is it just going to discard all that data, or is it actually going to give me whatever it was able to create? Um, I don't think it's going to give me whatever it's able to create. Mostly because usually when there's these kinds of errors, especially in Python, it's just going to like give you some kind of exception. It's not going to like gracefully exit. I could be wrong though. I could be completely wrong about this, which is why I need to test this out. Which, okay, to be honest, if the entire process does not take more than a few minutes, like imagine a 2.5 hour audio file, if it only takes a couple of minutes to transcribe, I don't think any of this is that big of a deal. I'll just feed a 2.5 hour audio file into pipelines and see and hope that the thing doesn't have an error. Because otherwise the other option, if I slice it, then I'm manually breaking this up, and wherever I'm doing the slicing, that's where I'm not going to be handling any broken words or any sort of stitching together of information or broken sentences or anything like that. Any repetition of words, like if there's words being repeated at the end of a clip and at the starting of the next clip, I'm not going to be handling any of that stuff, right? If I'm manually slicing a 2.5 hour VOD into like 30 minute chunks, then I'm not going to be handling any of that stuff. So whatever is within that small time frame, that's just like we can't really do anything with that. And that's not really that bad, but if possible, I would like to process the entire thing as one, so that we have like one transcript for the entire thing. Okay. That being said, I do unfortunately have to um, end because this is completely on me. I started the stream late. I shouldn't have done that, but I got a little busy with some other stuff. But I do have to end right now because I have some stuff to do. However, I am gonna be dropping a raid into somebody. So give me a second here. I'm just looking at the category and I'm gonna see. Okay, dilly dallying. Okay, I like that. I think I've rated this person before. Maybe I'm not sure. Just a second. I'm opening people's things up to see stuff and do stuff. Okay, can't do that stream. I can probably do this stream though. I think, dude, I think I remember this name. Yeah, I think I have rated this person before. Um, but yeah, we're gonna go over to this person's stream. Their name is Marmalade Little or Marmalade Lil. Yeah, Marmalade underscore Lil. So that's gonna be it for today's stream. Guys, thanks a lot for hanging out. Um, Siva, thank you very much for hanging out and chatting. Appreciate it. Anyone else who might have been lurking in the stream, thanks for hanging out. We've made some amount of progress. I mean, I made progress in terms of learning things, so I'm happy about that. I'm gonna spend some time looking into the logic for slicing. I haven't actually tested out the slicing mechanism. That's what the slicing functionality uh, through FFmpeg directly. So that's one thing I have to test out. And the next thing I need to test out is how well does Pipeline handle a 2.5 hour audio clip? But yeah, that's going to be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.